What are the current challenges of applying artificial intelligence in glioma imaging, and what are the technical solutions to those challenges? You can find answers in this review paper, Artificial Intelligence in Glioma Imaging, Challenges and Advances. Gliomas are one of the most devastating cancers. The most aggressive type, glioblastoma, accounts for 45% of all gliomas, and affect patients have a 5-year survival rate of only 5%. Brain image techniques such as CT and MRI are non-invasive, relatively cheap, and accessible to patients. Thus, they are the most essential assessment tool for clinicians. The large amount of brain image data requires novel computational methods to analyze and extract clinically relevant information. Over the last 2 decades, there has been an increasing interest in applying AI, namely machine and deep learning, in glioma imaging. Machine and deep learning techniques have the potential to increase the clinical yield of non-invasive imaging studies, from segmenting tumors for quantitative measures to identifying molecular subtypes and grades, from evaluating treatment response to predicting patients' prognosis. Despite recent advances, AI technologies has not yet become fully functional in clinical management of patients with gliomas. These challenges involve the full life cycle of developing an AI model, from the initial step of obtaining the training data to training the AI models, to evaluating and deploying the AI model to clinical settings. In our paper, we review the recent advances in glioma imaging research addressing the 3 main challenges. First, to overcome the challenge of data paucity, we summarize different image imputation and synthesis techniques along with annotation collection efforts. Next, we present various training strategies to meet multiple requirements, such as model performance, generalizability, data privacy protection, and learning with sparse annotations. Finally, to facilitate the clinical deployment process, we review the standardized performance evaluation and model interpretability methods. We also propose necessary future steps towards clinical workflow integration and provide a framework for evaluating the clinical utility of AI systems. We believe that those technical approaches will facilitate the development of a fully functional AI tool in the clinical care of patients with gliomas.